Hi friends, today we are going to discuss a very important derivation from the chapter Motion in a Straight Line. We can discuss the kinematic equations for uniformly accelerated motion. We have already studied the three equations of motion, right? What are the three equations of motion? Yes, that is V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Here we know that what is V? V is the final velocity, and what is U? U is the initial velocity, and what is A? A is acceleration. Then T, that is time, right? Then what about S? S is the displacement. Then all these quantities we know, right? Then today we are going to discuss the derivation for the kinematic equations. That means these three equations by using the graphical method. So we can derive the three equations of motion for uniformly accelerated motion by using the graphical method. Here we can see the graph, that is the velocity time graph for uniformly accelerated motion. We have already studied that in the case of uniformly accelerated motion, the velocity time graph, how it will look? Yes, that will be a straight line with a positive slope, right? Here we can see, that is the time is taken along x-axis and velocity along y-axis. Okay, so when we draw a graph, the shape of the graph will be like this. That means AB represents the shape of the graph. So it is uniformly accelerated motion, so that it will be a straight line with a positive slope. Here we have a positive slope because this is positively accelerated motion. Now we can just take the points as A and B. This is the shape of the graph. Then we can take the slope as here we can join this A and C because we have the slope here. That means BC by AC, that is the slope, y by x, right? So this distance can be taken as t, that is time, and V0 is the velocity at a time t is equal to 0. That means this is the initial velocity. And here we can see V, this is the final velocity, that means the velocity at a time t. Okay, now we have joined these points and now we can find the first relation. Which is the first relation? That is V is equal to U plus AT. Now the first relation we can find, that is velocity time relation. So here we have to find the acceleration. In the case of velocity time relation, that is V equal to U plus AT. This equation we have to find. For that, we are taking this equation, that is acceleration we have to find. How we will find the acceleration? That is change in velocity by time. Okay, so here we have a velocity time graph. So from this graph, how we can calculate the acceleration? Here we know that the slope of the graph will give the acceleration, right? So how we will find the slope? That is y by x. That means BC by that AC. So what will be the BC here? BC means here we have the final velocity as V at this point, and till this point it is V0, right? So in between these, how will be the value? How we can find the value? That will be V minus V0, right? So we will get this distance, that is BC. Then what will be AC? Here it is same as that of T, time. So we can substitute the value. So here we have the y as V minus V0 and here time is t, that is x. So y by x we are getting as V minus V0 by t. Okay, now we have to find this V minus V0. We can cross multiply here. That means V minus V0 will be equal to A into T. That is V minus V0 is equal to AT. Okay, here our equation is in the form of V is equal to, right? So we can keep this V only in LHS, then V0 will come to other side. So what we will get? V will be equal to V0 plus AT. Here instead of U we are taking as V0. Okay, that means this is the initial velocity. So this is our first equation. Is it clear? That is V is equal to V0 plus AT. So once again I will repeat. First of all we have to find the velocity time relation. For that we are finding the acceleration from the velocity time graph. Okay, so the slope of the velocity time graph will give acceleration. For that what we will do? The y by x we have to find. Y is bz here. So that will be v minus v0. Okay, so this distance we will get. And what about AC? That is the time itself. So v minus v0 by t. Then if you are cross multiplying, that is a into t, that will be equal to v minus v0. So that we can rearrange to get v is equal to v0 plus at, that is equivalent to v is equal to u plus at. Is it clear? This is only two steps are there to get the first equation. Now we can derive displacement time relation. Which is the displacement time relation? Yes, that is s is equal to ut plus half at square. Right. So again we can consider the velocity time graph. It is shown here and it is a uniformly accelerated motion. So the diagram is same for all the three equations. Okay. So that we have to find the displacement from this graph. Is there any way to find displacement? Yes, we have studied in the case of velocity time graph, the area under the graph will give the displacement. Right. So which area we will get here, which is the area below the graph, hold this area, right? Here we have this area, this is a triangle, right? And what about the below side? Here we have a rectangle, isn't it? So how we will find the area? This is the rectangle and this is the triangle. Okay, so how we will find the total area? Yes, that is area of the rectangle OACD plus area of the triangle ABC. Okay, so like that we can write down. Within 3 steps we can find the equation, that is the displacement time relation. Okay, it is very easy, but it is an important question for your board exam. Okay. So how we can find the area of OACD, that is the rectangle? Yes, that is OA, that is OA is, how we will find OA, that is V0, right? So V0, initial velocity, and OD, how we will find? OD is the time itself, so V0 into T plus half, in the same way we can write down, then into AC. What is AC here? AC is OD itself, right? That is the time. So here T, and then BC, how we will find? This is BC. So how we can find BC? The total velocity minus this V0. So we will get this portion, isn't it? So that only this portion we have to find, BC. So how we will find? The total velocity minus initial velocity, right? V minus V0. So we can write it as V minus V0 into T is here. Okay, but we have already studied that V minus V0 is equal to A into T. From the first equation we are getting such a relation, right? Can we substitute it for V minus V0? So what we will get? S will be equal to V0 T plus half T into AT. Here V minus V0 is AT. So what we can write? That is S is equal to V0 T plus half AT square. Okay, so that is the second relation, that is displacement time relation. Don't be confused with this V0 because this V0 is same as that of the initial velocity U. So that we are getting the second equation. I will just go through the relations again. Here we have to find the displacement, right? So how we will find the displacement from velocity time graph? Yes, that is the area under velocity time graph is displacement. So the total area we are finding, that is the area of the rectangle plus area of the triangle. Area of the rectangle is length into breadth, that is OA into OD. Okay, so that will be V0 into T plus half into AC into BC. That is AC is time t and BC is V minus V0. Half BH is finally here, right? So that will be V0 t plus half t into V minus V0. And we are substituting AT instead of V minus V0. So what we will get? S will be equal to V0 t plus half AT square. So this is the proof on the basis of graphical method. Okay, this is very important. Please don't leave this question. Okay, now we can move to the third equation of motion, that is the displacement velocity relation. Okay, what was the last equation? That is v square is equal to u square plus 2s, that we are going to derive. Okay, so the same diagram we have again, that is the velocity time graph. Here the time is taken along x-axis and velocity along y-axis, and the graph is as shown here. Okay, the same graph we are using for three equations. So that here we have to find the displacement again. Okay, displacement velocity relation is here. So again we have to find the displacement from the graph. So how we can find the displacement? Yes, we have already told that the area under the graph will give the displacement. So here we have the area here. That means the triangle and rectangle is here, right? So this is a trapezium, isn't it? Now we can find the area of the trapezium, because our equation is b square is equal to u square plus 2as. We have to get the equation in such a form. So what is the area of the trapezium? Yes, that is a is equal to half into a plus b into h. Here that a plus b we can take as a as one side, that is BD. This distance can be taken as A, and the other side, this distance can be taken as B. Now that is A plus B means these two sides, then the other side, that means OD, that is time, can be taken as H. So now can we find the equation, that is displacement is equal to area of trapezium, that is half into a plus b into h, right? So how we will find half into a? What is a here? A we are taking as db, right? So here a is v, this distance bd is v, so that v we can write. Then what about b? That distance v0, isn't it? So v plus v0 into here v plus v0 into h. H is the height here. So this OD is taken as h. So what it will be here? T. So into T. That means half into v plus v0 into T. Now we can give a substitution for T, because there is no T in our equation. We have already discussed in the first equation, that is v minus v0 is equal to AT, isn't it? So by using this equation we can find T. How we will find T? T will be equal to v minus v0 by A. Okay, when we are rearranging this we will get it as v minus v0 by A. Clear? Now can we substitute the value of T here? So what we will get? S is equal to half into v plus v0 into v minus v0 by A. That is, here it is like a plus b into a minus b. So what we will get? A plus b into a minus b is equal to a square minus b square, isn't it? So how we can write? This 1 by 2a is coming here, and this portion is v plus v0 into v minus v0 will be v square minus v0 square. That is, s is equal to v square minus v0 square by 2a. Okay. Then we have to write it in the form, that is v square is equal to u square or v0 square plus 2as. So we can cross multiply here, that is 2as will be equal to v square minus v0 square. When we are rearranging, what we will get? V square is equal to v0 square plus 2as. Is it clear? Now this time I will explain it once more. That is, here the displacement velocity relation we are finding, right? So how we can find the displacement from a velocity time graph? That is the area under the graph. So this is a trapezium. So we can find the area of trapezium. That is, A will be equal to half into A plus B into H. Here A we are taking as BD. This side we are taking as A and this side as B. And this portion, that is OD, is H. So we can substitute the values. So that will be half into V plus V0, because V is BD plus V0 is OA into H, that is time. And here we are giving a substitution instead of T. That is V minus V0 is equal to AT. Therefore T will be equal to V minus V0 by A. So when we substitute this value, what we will get? Half into V plus V0 into V minus V0 by A. That will be equal to V square minus V0 square by 2A, because this is the case of A plus B into A minus B, that is A square minus B square. When we are rearranging, what we will get? V square is equal to V0 square plus 2AS. So this is the third equation of motion. Now we have discussed all the three equations of motion. Hope it is clear to you. Today we are going to conclude our video. If you like my videos, please like, share and subscribe. Thanks for watching.